Let's combine some power series, huh? Let's get away from interval of convergence and radius of convergence. Let's talk about combining some power series. So we're going to have a big old theorem here, and it's like, oh, goodness. Why? So we're saying that you can take, like, I'm just going to really simplify this and then show it to you in a problem, because I think inside the problem you're going to look like, oh, okay, no, that's actually not terrible, but the work makes it seem crazy. It's saying you can add two series together. You can also subtract two series. You can multiply two series together. You can do that, and it's still going to work out. You can replace your x with something else. You can plug it inside of a function. You can still get another answer. And I'm just going to leave it at that. Let's move forward, and let's see it inside of a problem. So we're going to be given some information, and we're going to work upon it. Now, we'll talk much more about this in the future. 1 over 1 minus x. It just works out nicely because the power series only turns into, it's just x to the k. It's very convenient. It's the simplest of all of them, which means that this can be approximated, or 1 over 1 minus x can be approximated with this polynomial, 1 plus, oops. Plus x cubed plus, sorry, I wrote that in incorrectly again. Sorry, your teacher sucks. And it has an interval of convergence from -1 to 1, because our center is 0, and a radius of convergence of 1. Well, let's see if we can't find this. And this is not bad. We want to make this, our problem, look like what's given. So let's take out an x to the 5th. Times 1 over 1 minus x. Well, we already know that. So we're saying we could just do this if you want to. We can leave our x to the 5th, and now we can replace our 1 over 1 minus x with what it's equal to. So 1 plus x squared plus x cubed plus ... and it goes on forever. Distributed. We're doing the multiplication rule. So you get x to the 5th plus x to the 6th plus x to the 7th. Sorry about that. I wrote a chi instead of an x. No, I'm not talking to you, Kai. That's my dog's name. Oh, I don't need that at the end anymore. We see, we just multiplied it. We just pulled out the x to the 5th. We're like, I'm going to make it match. I'm going to make it match. All right, cool. So that's the multiplication rule. Well, I don't think we're going to see an addition rule here. But now we want to make this one kind of match up with this. And you're like, well, that's not going to happen. But we could just write it like this. 1 over 1 minus 2x. Where we're going to replace every x with 2x. With 2x. So we're going to have our 1 plus our x squared plus our x cubed plus our ... It goes on forever. And instead of writing in x, we're going to write in 2x instead. We're now doing the composition rule. We're saying, well, dude, as long as we can get in that form of 1 over 1 minus blah, we can throw that frickin' blah inside of there. So it turns out that this is 1 plus 2x plus 4x squared plus 8x cubed plus 16x to the 4th. They can just keep on going. And there's our new power series by using these formulas. And this is going to be incredibly powerful. Sorry about the pun, power series. But it's going to work out beautifully. Now let's do this last one. And we're like, okay, well, let's get this in that form. 1 minus negative x squared. Is that the same thing? The negative is not inside with the square. It's just negative. A minus is a plus, is it not? Oh, it is. So now we can take everywhere we see an x, we're going to replace it with negative x squared. We're now doing the composition rule again. So we can state that this is going to be 1 plus something plus 1 plus something squared plus something cubed plus ... It goes on forever, right? 1 plus something squared. And now we're going to take that negative x squared and we'll just pop it in. The composition rule. So we'd end up with 1 minus x squared. Now we're going to square a negative, so it's going to turn positive, and we get x to the 4th. A cubic, we'll keep that negative, and 2 times 3 is to the 6th. We'd have positive x to the 8th minus x to the 10th plus dot, 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 and it's going to go on forever. These are our rules for combining power series. And they're not that bad. That's not that bad. You just need to know how to set them up. But what we've done is we've set these pieces up, but I want to take it a step further because I wanted you to catch the point. So for our first one, we ended up with x to the 5th plus x to the 6th plus x to the 7th plus x to the 8th plus dot, dot, dot. Let's write this as a sum. Let's write this as a sum. Let's start at 0, and let's go to infinity. So we're going to have x. They're all x's in the bases, right? Well, how do we make this is the 0th term, the first term, the second. So what's the difference between the 0th and the 5th and to the 5th? And what's the difference between 1 and 6? And what's the difference between 2 and 7? 5. The difference is 5. So in order for us to get our first one, we need to write in k plus 5. So when your index is 0, you get x to the 5th. When your index is 1, you get 1 plus 5, which is x to the 6th. And we got our sum. Cool. Neat. And now we have to do it down here. Now, I wrote it all out just to show you, but I wouldn't deal with that. I'd probably deal with what's up top, where we have 1 plus 2x to the first, plus 1 plus 2x to the second, plus 1 plus 2x to the third, plus dot, dot, dot. And now we want to write up the sum, but that's not so bad. That's from k equals 0 up to infinity. And this is all going to work out with the powers, right? 0th term doesn't have any x's. The first term has something raised to the first. Second term has something raised to the second. So this is merely 2x to the k. Just taking it a step further. And lastly, but not leastly, let us deal with the third one, where we had our 1 minus. Well, I think this one might be better for us to look at it where it's simplified. And how do we set this one up? Ooh. So it's the sum from k is equal to 0 up to infinity. And let's write this in. Our 0th term, our first term, our second term, our third term, our 4th term, and our 5th term. This is going to be really helpful for building them. So we're good on the 0th term. That works out fine. But it looks like, let's deal with the signs first. Let's deal with the signs first. So odds are negative. Evens, right? Odds are negative. And all of our evens are positive. So I think we could just change the signs. We can do that little oscillation by just saying it's -1 to the k. All right, so when you have an odd k, it's going to be negative. When you have an even k, it's going to be positive. Well, that worked out nicely. I don't know why I drew it so high up. There's no denominator here. Let's just bring it down. Oh, and now we need to figure it out. We're like, well, we can see there's an x inside of each one. So it's x raised to a power. Now let's look. First term, it's 2. Second term, it's 4. Third term, it's 6. Fourth term, it's 8. Fifth term, it's 10. So when k is equal to 1, the exponent is 2. When k is equal to 2, the exponent is 4. Bruh. It's x to the 2k. It's saying just double up. Every term, I need you to double up your exponent. There would be. There would be. We're good. All right. Now we could talk more on this. I could take you even further and be like, all right, now what's the radius in the interval of convergence? But I want to stick to one thing at a time. I don't want to continue doing this. I'll speak on it. I'll just speak on this. We already knew from the freaking beginning. We already know. We already know. The absolute value of x needs to be less than 1 away. So it's negative 1 to 1 is our IC, and our radius of convergence is 1. We go to our next one, we look at that, and R is equal to 2x, needs to be less than 1, so the absolute value of our 2x needs to be less than 1, so that's 2 times the absolute value of x is less than 1, so the absolute value of x needs to be less than 1/2, hence our radius of convergence is 1/2, and our interval of convergence, wow, we're not going to use any of these endpoints, it's going to be negative 1/2 to 1/2. Lastly, but unfortunately not leastly, we're going to take all of our squareds. We're going to put those inside of there. We're going to take those and we're going to say that these x squareds that are inside of there need to be away from 1. Thus, the absolute value of x needs to be less than 1, and our interval of convergence is negative 1 to 1 with our little r being 1. But I didn't want to do the work. I just kind of wanted to state it. Yes, there's work to do. I jumped past all the stuff. But can you plug stuff in? Screw all the end parts, right? I made you do a little bit more practice with it. But could you get these? Could you plug them in? Could you replace and see what sort of stuff we get? And then if you could do that, could you take them and actually write a whole thing as a sum? Let's see if we can't do that game. I won't combine too many games inside a test. I'll try and keep them fairly simple to where you only have to do like 1 or 2 things. But I think that's a good spot to stop. And then we're going to talk about differentiating and integrating power series. I think we're through the majority of it now. We're through the majority. Even like 11.3, 11.4 won't be all that long, but we will do some stuff. Or maybe I'm lying. I don't know. It's been a while. All right.